Okay, so today we're going to start with the properties of definite integrals. Okay. Which really are the same as the properties for indefinite integrals. Except for, well, maybe this first one, the integral from a to a of f of x with respect to x is equal to 0. Because remember, your integral is basically measuring your area. So you can't really measure the area from one space to the exact same spot. So the integral from a to a would just be 0. 2, the integral from a to b of f of x with respect to x is equal to the integral from b to a, but just the negative of it. So whenever you flip your, I guess you can call them interval terms, just make it negative, same thing. Okay, and just like with indefinite integrals, the integral from a to b of f of x, either plus or minus some function g of x with respect to x, is just equal to the integral from a to b of f of x, either plus or minus the integral from a to b of g of x. Okay, and number 4, the integral from a to b of a constant times a function of x. Again, that constant can just be brought out to the front. Bring it up a little bit. Okay, and the last one, the integral from a to b of some function of x can be equal to the integral from a to some constant c plus the integral from c to b. Okay. So unlike you did with the summation, you don't have to add 1 here. But the integral, it just goes from a to c, then picks right back up at c. Okay, leave that up there for a few more seconds.
So is that like the summation? Was that the E looking thing?
The E looking. Oh, you mean the summation? Oh yeah. That's a little bit different because with summation, you have the sum from a to say a to some n.
Yeah.
It could be from a to n, or a to, let's say, some number b, and then it would pick up plus b plus 1
Right.
to n. So with that one, it's a little different because it just goes from a to c, then again from c to b.
So it includes C.
Yeah, it includes it.
So versus
C is somewhere between A and B.
Yep, c is somewhere between a and b.
Okay.
So it'd be easier to describe it as A to C than A to B to C, not B to C.
Only if your beginning integral is from a to c, then you
Yeah,
could.
that's what I'm saying. Wouldn't it be easier to describe it that way? That way people can see B as in the middle or from,
I guess as long as you understand the general idea behind it, if you wanted to substitute it with a to c or a to b, then b to c, you could. All right. Okay, so let's say, for example, you wanted to evaluate the the integral, oh, that should be a 0. Oh, did I lose my eraser? Yes, I did. And this one's just about gone. Okay, so from 0 to 1 of -6 times f of t minus 4 times g of t. With respect to t, if you're given that the integral from 0 to 1 of f of t with respect to t is equal to 5, and the integral from 0 to 1 of g of t with respect to t is equal to 8. Okay, so just like with the summation, you can just distribute your integral. Okay, so if you have your integral from 0 to 1, if you distribute it to the -6 f of t, you can just bring the -6 right out to the front of f of t with respect to t. Minus, you can go ahead and just bring the 4 right out to the front. The integral from 0 to 1 of g of t with respect to t. Okay, so we know here the integral from 0 to 1 of f of t is 5, so that gives us -6 times 5 minus 4. We know the integral from 0 to 1 of g of t is equal to 8. And then from there we just solve. Okay, so -6 times 5 is -30, minus 32, which is -62.
This stuff wasn't on the last test?
And trying to think if it was for the summations.
I studied it.
Yeah, I think it could have been for the summation. Yeah, because the last test stopped at 4.10.
I think I wasted time studying it.
Yep, and that was in chapter 5. All right, so any questions on that one? All right, so let's say, oh, I'm still writing. All right. Okay, so let's say, for example, we wanted to evaluate the integral from p to 4 of f of x with respect to x if the integral from 4 to 11 of f of x with respect to x is equal to -6, and the integral from 11 to p of f of x with respect to x is equal to 5. Okay, so you notice here we have from 4 to 11, and we have from 11 to p. But here we have from p to 4. So we want to switch those two up. So you want to remember that the integral from a to b of f of x with respect to x is equal to the negative of the integral from b to a of f of x with respect to x. Okay, and we also know that the integral from a to b is equal to the integral from a to some constant plus the integral from that constant to b. Okay, so that's what we're going to use to figure this one out, those two. Okay, so this, we know that the integral from p to 4 of our f of x is equal to the negative integral from 4 to p of f of x. Now, since this one goes to 11 and this one picks up at 11, that means we can get this and make it the negative from the integral from 4 to 11 of f of x with respect to x, plus the integral from 11 to p of f of x with respect to x. Okay, so we know the integral from 4 to 11 is negative 6. Plus, the integral from 11 to p is 5. Okay, so that's going to equal negative 1, which is just 1. Okay, so most of the questions like this are just ways to manipulate the properties. All right, any questions on this one? All right.
Can you go back? How'd you get -1 from? Oh, never mind.
Oh, you got it.
Never mind.
Oh,
Yeah.
okay.
Sorry.
Oh, no problem.
So you had to put the P on the top.
Yep, and the only reason is because we couldn't go from 4 to 11 and then 11 to p as long as we had the p at the bottom.
Okay.
Yes.
Why is our negative on the outside of the brackets?
Oh, because here it's just like -1 times this
Right.
integral. So when you get this integral and you just separate it, you just still have the -1
Right.
times that.
When we distribute the -1, we'd end up with negative 11 to 4, I guess, minus that, right? We'd end up subtracting.
Oh, you mean if you just distributed it from here?
Yeah.
Oh yeah, you'd have negative f of x plus negative
And that doesn't necessarily.
f of x. So that just becomes negative of -6, which is +6, plus 5, which, minus 5, which is still 1. You would just kind of skip this last step. All right. So there are a couple of different ways you could have done this one. All right. Any questions on this one? Or any other questions?
How do you know, sorry,
Mm-hmm.
how do you know that 11 is between 4 and P? Or, sorry, 4 is between 11 and P? What the original was, so yeah. No.
Oh, we just go by what they gave us.
So you always just go by what you.
Yep. So if they gave us that, then that's the one we'll go by.
Okay. But if there's no way for you to know, besides them giving that, that 11 is actually between 4 and P.
Isn't it that in an integral, because I don't know if he said this yet, but in an integral, the bottom number is always going to be lower than your top number. So that's how we would recognize that.
Yep. So you're always going to have your a less than equal to x less than equal to b. So if this is your integral from a to b, pretty much you're just going, I guess you could say to the right on the number line. So that's why your a is always going to be lower.
Okay. And so that's why when you flip it, you have the negative sign. Right?
Oh yeah, when you flip, oh, I see, oh, you're on this step here.
Yeah. So
Yeah, when you flip, you just have the negative of what it would have been anyway.
Right, okay. So, all right, I was just curious, how do you know 11's in there?
So if it would have been from 4 to 20 and 20 to p, we would have just used 20 instead.
So if you have the unknown variable like p,
Mm-hmm.
do you automatically know to use like property number 5 that you showed us?
It depends on the problem, but with one like this where they give you some type of, continuation,
Like
then
an
you,
endpoint with a variable in the middle. Basically.
exactly. So then you want to use that one. But let me see if I can find. Yep, so actually this next one is a little bit of a twist on it. Okay, so let's say, for example, we're given that the integral from 1 to 26 of f of t with respect to t is equal to 1, and the integral from 3 to 26 of f of t with respect to t is equal to 10. And they want us to find the integral from 1 to 3 of f of t with respect to t. Okay, so this one's just a little bit different. Okay, so once again, we're still going to use the one we're going to break this up. But this goes from 1 to 26, this is from 3 to 26, and they want us to find from 1 to 3. Okay. Now just using that, the one thing we can say for sure is that the integral from 1 to 26 of f of t is equal to the integral from 1 to 3 plus the integral from 3 to 26. Okay, so that's what we know for sure. All we did was just separate 1 to 26 in two different sums. Okay, so we know the integral from 1 to 26, that's equal to 1. And that's going to be equal to the integral from 1 to 3 of f of t, because we don't know that one, plus our integral from 3 to 26, that's equal to 10. So if we subtract 10 from both sides, we end up with negative 9 equals your integral from 1 to 3 of f of t with respect to t. Okay. So it's all about just recognizing a pattern with your upper and lower integral limits. All right, any questions on that one? All right, so let's do one more. Okay. All right, so let's say, for example, if we're given that the integral from 0 to 10 of f of x with respect to x is equal to negative 4, the integral from 0 to 1 of f of x is equal to negative 3. The integral from 0 to 10, I wish I...
That's 0 to 1, you said?
Yep, 0 to 1. The integral from 0 to 10 of g of x equals 5. And the integral from 0 to 1 of g of x equals negative 5. Okay, and they want us to find the integral from 0 to 10 of f of x minus 3 times g of x with respect to x.
So you're doing the same thing you did on the last one, but for each function, f of x and g of x, and then subtract them.
You would think so, considering how much they gave you. But the thing is, if you have the integral from 0 to 10 of f of x minus 3 times g of x, if you just distribute that, you have the integral from 0 to 10 of f of x minus 3 times the integral from 0 to 10 of g of x.
Yeah. That's what I'm saying.
All you need is this one and that one. They just threw those in there to confuse you. So sometimes you don't need all of them.
Okay, I get it.
Yep, they just did that to.
Because you gave pretty much the A to, let's say you gave the A to B arc, and then you gave the A to Z. But all they were asking from the equation was A to B.
Yep, that's it.
Yeah, I get it.
Yep, so sometimes they'll just throw extra ones in there just to see if they can throw you off. Okay, so from 0 to 10, our f of x is equal to -4 minus 3 times from 0 to 10 of our g of x, which is 5, which is -4 minus 15, so that's -19. Like I said, so those two weren't even necessary. All right, any other questions on this one?
So they'll do that sometimes just to confuse you.
Oh yeah, just because. I guess just to see if you're paying attention. The thing is, if your answer is looking for 0 to 10, and you have two 0 to 10s that will just work out,
Like if you had a 0 to 1 and then 1 to 10, you would then do it the way that I said it.
only if you had to.
Yeah, that's what I'm saying.
So if they had a 0 to 1 that was equal to, let's say, 4, and 1 to 10 that was equal to 1, you go from 0 to 10, that would still be 5. So if you did that, it would just be a little more work, but you'll get the same answer. So it really depends on if you need it or not.
That from 0 to 10
Mhm.
distributes into the minus 3gx.
Yep, the minus 3gx, yep. All right, any other questions on this one? All right. Okay, so now, see how much time, oh yeah, good on time. We're gonna look at the comparison theorem. Okay, which states if you have some function of x which is greater than or equal to 0 for, let's say, some x in the interval a to b, which is just another way of saying that x is an element of the interval a to b. Remember, that just means an element of. Okay, so if this is the case, then the integral from a to b of f of x is greater than or equal to 0. So if the function is greater than or equal to 0, then the integral will be greater than or equal to 0. Okay, so the second one, if the integral, not the integral, skipping steps. If f of x is greater than or equal to g of x for some interval from a to b, then the integral of f of x is greater than or equal to the integral of g of x. Okay, and third, let's say if lowercase m and uppercase m are constants, where your lowercase m is less than or equal to our f of x, and our f of x is less than or equal to our uppercase M, for some interval from A to B. Then lowercase m times b minus a is less than or equal to the integral from a to b of f of x with respect to x, which is less than or equal to the uppercase of m times b minus a.
And what is the lowercase m and uppercase m again?
Yep, just constants. It's any constant.
Just two different constants.
Yep. Well, they could be equal if everything is equal right across the board.
Right.
But we're just calling them two different because they could be the different constants. They could be the same. So we just kind of left the option open by not making them the same thing.
Now, when you said it was an element of,
Mhm.
that basically means that x, like, there's a variable in between the interval of a and b that
Yeah.
is x.
Yep, it's x.
So like 1 to 10, x could be 1 to 10.
Yep, it could be 1, it could be 1.5, it could be anything in between 1 and 10.
Yeah.
Yep.
Like
Not-
equal, equal.
And equal.
Yep, or equal to.
Or equal, okay.
Yep, because it's a bracket.
Right.
Yeah.
All right. So let's, oh, anyone's still writing? All right. Okay, so let's say, for example, if you're given that uppercase f is equal to the integral from 10 to 13 of 7x squared plus 3 with respect to x, and uppercase g is equal to the integral from 10 to 13 of 6x squared plus 5 with respect to x. Which of the following are true? Okay, so let's say for option A that f is greater than or equal to g. For B, uppercase f is less than or equal to g. For option C, f is less than or equal to 9. Or D, g is greater than or equal to 15. All right, so for problem A, let's say if we let our f of x equal 7x squared plus 3, and our g of x equals 6x squared plus 5. Okay, so we can see here that 7x squared plus 3 is greater than or equal to 6x squared plus 5 when x is between 10 and 3.